Hello viewers, welcome to uVolve, the channel for database and data professionals. This is the fourth part of the topic on a simple project in the field of data analytics using Kaggle, Python, Oracle Database and Microsoft Power BI, and in this tutorial we are going to perform the ELT activities, that is the extract, load and then transform activities on a dataset that we download from Kaggle. So viewers, in the last three parts in this topic, we created our software environment with the Python, Oracle Database and Microsoft Power BI and did the ETL activities on the dataset that we downloaded from Kaggle, and we did our data analysis using Microsoft Power BI. If you have not watched the previous parts, I suggest you watch them first to get a better understanding on what we are going to cover in this part 4 today. I have made this part 4 only for those who are particularly interested to know about Oracle Database and its capabilities in the field of ELT, that is extract, load and transform. In fact, if you know a little bit of SQL in Oracle and PL SQL, that is programming language with SQL, which is a very powerful yet simple database programming language, you don't have to look for or know any other ETL tools to transform or clean the data, because PL SQL will do everything for you. So what we are going to do in this part 4 is to download the data from kaggle.com using just the browser. As we normally download a file, then we will directly load it into Oracle Database. Then we will clean and transform the data using simple SQL and PL SQL code. Then using Microsoft Power BI application, we will pull the transformed and clean data for data analysis. We will not write any Python code for ETL activities like we did previously in part 2 of this series. Rather, it will be ELT activities which will be performed solely at the Oracle Database level, and we will use SQL and PL SQL. So without further delay, let's start. First, let's log into our Kaggle account to download our data, and you search for the dataset, that is employee salary data from uVolve data, and it will take you to the dataset directly. Then click on the employee salary data, scroll down, and then we will download this emp salary data.csv. Then click on this download button here, and the download has been completed, just 37.2 KB. Let's go to the download folder, and this is the file emp salary data, which is a comma separated value file. Let's open it and see the contents in a text editor. So open with Notepad, and here we see the data and all the values are comma separated, and the top line or the header line being the name of the columns, that is employee ID, first name, last name, department, join date, monthly salary and birth date. Let's close it. So we have our data downloaded and it is currently available in the downloads folder. Next, we will go directly to the Oracle Database to load the data in the CSV file to an Oracle table. Please note that the Oracle Database software we installed in part 1 of this series was Oracle version 21C, but this method will work on any older version such as Oracle 19C or 18C or even latest Oracle Database version 23AI. So let's minimize the browser and bring up our SQL developer application to connect to the Oracle Database. So we have two saved connections there to the database name xepdb1 with our application user named app user, and the second saved connection is with the user system, which is the database administrator. So let's first connect to the database using the administrator, that is the system user, because we have some administrative work before we can start working with the data. So right click and then select connect, and the first session is established with the system user. Now let's establish one more session with the application user also. So right click and then select connect. So we have the second session here. Now let's go to the first session, and the first step is to let Oracle Database know where our data file, that is the CSV file, is present, and that is by creating a directory object in the database. So a directory object in the database points to a physical directory or location at the OS level. So we will create the directory object that will point to the downloads directory or folder in Windows. And the command will be, I am just copying and pasting the commands to save time. And the command is going to be create or replace directory, name of the directory, that is ext_dir, as within single quotes we are specifying the path, that is C:users win10 admin, that is the current user with which we log into this Windows machine, and then the downloads folder. You can assign any name of your choice to this directory object. Then we'll select the line and then we will execute. Please note that we are executing this command as the administrator, that is system user. So the directory object extdir created. Next, we are going to grant access to this particular directory object to our application user. Again, I am copying and pasting the command, and that is grant read, write on directory extdir to our application user, that is app user. So select this line and execute, and the grant succeeded. Now we will go to the session that we established using the app user, and here we are going to create a table to load our data in the CSV file. Again, I am copying and pasting the command here, and then I'm going to explain. So the first line, that is create table emp_salary_data_stage. So the word stage I'm adding at the end because I'm going to use this table as a staging area for the unfiltered or dirty data. And then we are going to do the cleanup and transform activities before loading to the actual table. So this is going to be a staging table only, so the word stage. And if you see, I'm putting the name of the fields exactly in the order that we were able to see in the CSV file. So first employee ID, then F name, that is the first name, L name, last name, D name, that is the department name, JD, that is the join date, M cell, that is the monthly salary, and the BD, that is for birth date. So this name does not matter. This is just for your understanding that to which field the data will be assigned to. All that matter is the order of the column names, because they will be assigned or mapped in the same order in which the columns are present in the CSV file. Also, you will see the data type I have put as variable character 2 or varchar 200. It is because varchar 2 accepts text data, so it does not actually care if it is an invalid number or invalid name or an invalid date. All it cares is the size, so I use the size 100 so it does not reject data due to size restrictions. 100 is a random number. You can select even 200 or 500 if you feel that 100 may not be enough, or even a CLOB data type altogether, that is the character locator object, if you are uncertain about the size of the data to be loaded. Then the organization external means it is an external table and not a regular table. The difference between an external table and a regular table, in simple words, is that an external table does not actually store the data. It just links the external data source and allow you to query, like in case of a regular table. But a regular table needs space in the database as it actually stores the data. In the next section, we have to mention a few properties or parameters which will define how the external table is going to link the external data source. So the first line, default directory extdir. This is nothing but the directory object that we created in the previous step using system user. If you remember, we created this directory named ext_dir, and that's the reason I gave the name as extdir, because it's going to point to the data source used by the external table. Then under access parameters section, I'm putting a couple of parameters there, like records delimited by new line. As we have seen in our text file or the CSV file, each of the records are delimited by a new line. Then fields terminated by comma, because it's a CSV file, so comma separated values are there, so each of the fields are terminated by a comma. Then missing field values are null. This will tell Oracle that if there is any field missing, then it means it's a null value. Then finally, we are specifying the location, that is nothing but the name of the CSV file. So employee salary data.csv is our file name, which is available to the physical location pointed by this directory object. And Now we are going to select this and then we will execute it as a script, and the table employee salary data underscore stays created. Now we are going to query this table using our simple select statement, that is select star from the name of the table and now if we execute this select query, it is going to fail, and the reason is privilege related. Let's execute it and show you what it's going to produce. And there you go, the error message. Let's expand this window and we see there are a couple of error messages. Data cartridge error, file emp salary data.csv in extdir not found. But we know that this particular file is actually present in our downloads folder, which is pointed to by this extdir object. And this is because Windows does not recognize it as a secure access to the file when our Oracle software is trying to access this file. Let me tell you the reason. When we try to access this particular file from our SQL developer application using SQL code, actually internally our Oracle software is trying to read the file. And Windows does not recognize that access as a secure access because it knows the download folder belongs to the current user named win10admin. So we have to let Windows know that this is a secure access, or we have to provide appropriate permission on the downloads directory. And to do that, let's bring up our Windows Explorer and then right click on the downloads folder and select the properties. Then go to security settings and we see a couple of permissions are already there for some default users like the system user. And please note that this is not the system user in our database, but it is the operating system level user. Then the win10 admin, that is the local administrator, and there is one more default account and the administrator account of this Windows, which is again a default account. So what we have to do, we have to add a new permission here, and to do that first we'll click on the edit button, and here we have to again click on the add button and then enter the object name to select. We will put everyone, select that line and click on the check names. And once we see the underline is put there automatically, it means that Windows is able to recognize it as a default user or account as everyone. Then click OK and then select that line at the top. Then from the permissions list for the everyone user, we are going to select the appropriate ones. That is, we need only read and write, not the others. So we'll uncheck the other boxes and only keep the read and write permission. And then click OK and the OK button again. And this time this select query should return the records or the rows from the table, that is our CSV file. And yes, if you see, all the records are there. Let's take a count how many records are loaded, and we see 526. If you remember, we have actually 525 records in this particular CSV file, but it has given 526. It's because it is also considering the header line as a record. So we have to get rid of this, and to do that we have to adjust the access parameters, and just by adding a line called skip 1, we'll tell Oracle that you need to skip the line number 1, which is the header line. And then we have to drop the previous table, otherwise it will not allow us to create the table with the new structure. So we'll put the command as drop table emp salary data stays. Let's execute it, and the table is dropped. Now we will recreate this table with the new parameter that we added as skip 1. Let's execute it as a script. The table is created, and then we will execute our select query again, and this time there should be 525 records and the header row is also gone. Count of records 525. So we are good now. But although we have got all our 525 records in this external table, this data in the staging table or the external table is actually dirty, because it may have data issues, for example, invalid name, invalid date, invalid salary, etc. So this data set is not usable until we clean it before loading to the actual table. As we can see, the first row itself has an invalid character in the name, and it's a hash character which is not acceptable in the first name field. Similarly, if you scroll down, you should be able to see more issues there, but we are not going to detect these issues manually. And also, this is a 525 records data set, and manual detection is although possible, but if you consider a data set which is having like 1000 records or million records, manual detection and fixing the records is not at all possible. Next, we are going to detect and fix the data issues in this data set without using any tools. If you remember, in the part 2 of this series, we detected and fixed the data issues using Python code. This time we will use Oracle functions, which is nothing but PL SQL code for our purpose. So let's make some room there. So PL SQL is the database programming language that comes free with Oracle database. There are different types of PL SQL objects such as procedures, functions, packages, triggers, etc. Let me briefly tell you about these objects. A procedure is a block of code with a name and created to perform specific task. A package encapsulates functions and procedures, etc. for easier manageability. A trigger is event-driven, meaning they are executed based on a specific event that it is created for, like when a record is inserted to a table or deleted or updated, someone logged into the database, or the database is shut down, etc. I am going to create 3 PL SQL functions to detect invalid names, invalid numbers, and invalid dates respectively. These functions are just 3 to 4 lines of PL SQL code and easy to understand. The code to create and the logic of the functions or any SQL command are explained in the description of this video below. You can copy them from there or make any modifications as per your requirement if you want. And I'm going to copy and paste the command to create our first function to detect the invalid names. So the first function is named as is_name, which will check if an input string is a valid name with acceptable characters and letters in it. If it finds all the acceptable characters in the input string as a name, then the function returns 1, otherwise it returns 0. And if we try to create this function, it will fail again. It's because the app user currently doesn't have the privilege to create any functions or procedures. So again, we have to go back to the system user session to grant appropriate privileges to this app user. So let's go back there. We'll simply copy the grant line and then grant create procedure to app user. So grant create procedure will grant privilege to create procedures and functions both to the app user. Let's execute it, and the grant succeeded. And then go back to the app user session, and then we will execute the create statement for the function. And please note that there is a slash at the end. When you execute it as a script, you may put a slash at the end. And then press the execute script button, and the function is named compiled. Next, we are going to create a function to check if a value is number or not. Let me put the code here, and then I'll explain. And this command is create or replace function is number. So this function will take an input value and it will test whether it's a number. If it is a number, then it is going to return 1, and if it is not a number, then it is going to return 0. So let's execute this code block as a script, and the function is number compiled. And the next function that we are going to create is to test whether a particular value is date or not. And then let me paste the code to create the function. And what it is doing, create or replace function is date, and then it is testing a value in D, which is input as a variable character to and then it returns a number based on its testing. So the logic is, if the value that we are testing is a valid date in the format ddmonyyyyy, then it will return 1, and if it returns 0 means it is an invalid date. So let's select this code block and execute as a script, and the function isDate is also compiled. Now all our 3 functions that we are going to use to detect the data issues have been compiled or created successfully. Now we can use them for our purpose. And how we are going to do that? We will make small modifications to our select statement. Let's copy it from the top. And then first we will test the first name field. So select star from employee salary data stage, where, that is the condition, is name, and within bracket we will supply the name of the field, that is f name, equals 0, means it is not a valid name. It will return all the records where the first name field is invalid. Let's see what it returns. And we see there are 2 records, and you see the first name field, this one has a hash character and the second one has a dollar character in the first name field. So it has returned the records with invalid first name field. So we have to fix them. Now using the same function, we are also going to detect if there is any invalid value or name in the last name field. So let's make a copy of the first statement, and we'll make just a small modification here, and that is going to be, instead of first name, we'll put last name. Let's execute it and see if there is any invalid last names. And we see it has returned 2 records where the last name field is actually invalid because this first one has a plus symbol in the name, which is not acceptable, and this one has 2 dollar characters in between, which is also not valid. Similarly, you can test other names. For example, the department name, if we use the same function, then it is going to point out a large number of departments as invalid because we do not put our ampersand character in the list, and it will consider it as an invalid character in the name. So you can make necessary changes in the isName function so that it can also accept the ampersand character as a valid character in the department name, and then you can test. This was just an example for your understanding how we can use the PL SQL functions to identify the data issues. Next, we will find out if there is an invalid date in the joining date or JD field. And to do that, again, we are going to make a copy of the previous SQL statement. Select star from employee salary data stage, where is date. This is the function that we are going to use against the field JD. So if it returns a 0, means there is an invalid date. Let's execute it. And it has returned a large number of records. Let's see how many. 18 records. And why they are invalid? Because you see 31st November is obviously an invalid date. 31st June, 29th February, these are all invalid dates in the join date field. Now let's make a copy of this statement and also find out if there is any invalid date in the birth date field. So instead of JD, I will use BD here and execute it, and it has returned nothing, means there is no invalid dates in the birth date field. Next, we will find out if there is any invalid value in the salary field, and to do that, our function is number, and the name of the field is mcell. Let's execute it and see, and it has returned 3 records. And if you look at the mcell field here, you see that there is an ampersand value in the monthly salary, which is not acceptable. There is a space in the second row, and in the third row also there is a space. Now it's up to you whether you want to discard the records with data issues in the first name, last name, joining date, or in the monthly salary field, or if you want to fix them before loading to the actual table. If it is quite obvious, you can fix the records. For example, if you remove the ampersand, 6,500 looks to be a valid salary field. But the joining date field, you never know. It means it's not fixable unless the provider of the data source gives you the correct values. Now let's fix the first name field. Let me copy the first SQL statement that was giving us the invalid first names and paste it below. Let's execute it. These are the two first names that we need to fix. And how we are going to do that? Again, we are going to use the inbuilt function called translate that we used before. So select fname, that is the original first name that has the data issue. Then we are going to use the translate function, and within that we'll put the name of the field, that is fname. Then we are going to convert these invalid characters, that is the hash character and also the dollar character, to space characters. So you have to put 2 spaces for the replacement string and then close the bracket. The reason is Oracle is going to translate each of the characters to the corresponding character in this third string that we are passing, and there are 2 spaces because the first character will also map to the first space, and the second character, that is the dollar character, will also map to the second space. And then we are going to execute it. First, let's see what it is doing. And we see the original first name field is with this hash character, and now it is converted to a space. Similarly, the original first name field in the second row has a dollar character which is converted to a space. Next, we need to remove this space character from both these first names with a blank character. And to do that, we are going to use another function called replace. So the replace function will take the output from the translate function. It also needs total 3 parameters. The first parameter is the value returned by the translate function itself, and then we are going to supply the second parameter as a space, which is going to be converted to the third parameter, that is the blank character, and then close it. So now we are going to execute it. Yes, we can see that the hash character and the dollar characters are gone. Please note that this is just an output. Actual data set is not yet cleaned up or fixed with this particular solution. It is just how we can fix it. Now similarly, let's execute second SQL statement that was used for detecting the invalid last names and execute it. And there we see there's a plus symbol and 2 dollar symbols. So let's copy our last SQL statement to fix the first name field, and instead of first name we'll use the last name here, and then we will do the same thing here, that is the plus symbol and the dollar characters in the name will be converted to space characters, and the space character will be converted to a blank character using replace function. And then also we need to modify the condition in the where clause. Let's execute it, and we see that the last name field is also fixed because the invalid characters were removed. Similarly, the join date field. If you think that you can fix the date value in the join date field, you can still do that, but I suggest unless you get the correct value from the data source provider, there is no point in attempting to correct the join date field. And the last field that has any invalid values is the salary field. So let's copy the statement that we used to detect the invalid salary and execute it. And here we see that again there are some ampersand character and space characters in the salary field which can be removed using the same technique that we used for the last two first name and last name values. So what we are going to do, we'll use the original field name, that is cell, that is the monthly salary. Then we will use the translate function to pass the cell field. Then the list of invalid characters, that is an ampersand character, which will be converted to a space character. And then we will enclose this translate inside another replace function. And then we will convert the space character with a blank character. And this should fix the monthly salary field. Let's execute it and see what it returns. And we see that the value with an ampersand was converted to the correct value, that is 6,500. And similarly, the space characters are removed and the values are converted to the correct values. Please note that this is just an output. Actual data set is not yet cleaned up or fixed with this particular solution. So we need to incorporate that in our actual data set. So what we are going to do, now we have to create another select statement, and that select statement has the conditions to discard any records that cannot be fixed and fix the records which can actually be fixed with the method that I have shown. So I'm going to use select star from employee salary data, and then we will first take all our records, that is the 525 records, next we have to make some changes here. Instead of star, we are going to use the actual field names here because we have to manipulate them. So first emp id, where we don't have to do anything, then the f name, that is the first name which has some data issues. And how we are fixing, we are simply copying the replace and translate function combination that we used to fix the first name, so that we can compare what was fixed. Press enter for a line break, and then we'll put the where clause for the condition, which was is name f name equals to 0. Let's execute, and we see that the first name was filled as expected. Similarly, we have to use the last name in the same SQL statement now. So put a comma there and a line break, and then we will use the last name field, comma, we will copy the replace and translate function combination from the second statement that we used to detect and fix the last name field, and put it after the comma. And then in the where clause, we have to also use the condition, and this time we'll use a or combination, because either of these can be true. The first name may be invalid, or last name may be invalid, or both may be invalid, because we want to see the records where either of these conditions are fulfilled. That is, the first name may be invalid or last name may be invalid. So let's see what it returns. It should return 4 rows. And yes, we see the 4 invalid rows and their corrected values are returned. Now if you see, the original field name was f name, and the name for the column where the corrected value is displayed has a system given name. If you want, you can also give one name for our understanding. So I'll just give an alias. To put an alias, you just mention it after the field or the calculation that you are doing. So I will simply put it as fname2. And similarly, for the last name field also, I will give a name as lname2. Let's execute it again. Yeah, now it is much clearer and easy to understand. Next, we are going to work on the monthly salary. So put a line break and enter mcell for the original salary value and the corrected value here, which I am copying for the third statement that we used to detect and fix the monthly salary, and paste it below. And the condition also is number is 0, and I'll add it using an OR condition, because now either of these conditions can be true. Let's execute and see the results. and we see the corrected values in the second field that was created. So let's give an alias as mcell2 as the corrected field. And all are corrected. Now if you see, I am using this where clause to put the conditions to list out only the records with some data issues in the first name, last name, or the monthly salary field. If we discard the where clause, it will still work for us and it will give us all the records, and out of those records it will fix the ones where there is a data issue. So let's execute it, and it has given, for example, if you see the first name field which was converted to the first name 2 field, and if there is no issue, it is just converting to the same value. Now we still have work to do for the invalid join dates. As I mentioned before, we are not going to fix the join date field where there is an invalid value. Rather, we are going to discard those records with invalid join date. So what we are going to do here, I'll put a condition so that the records with the invalid join date will never come. So where clause will be added, and we will select only the ones where join date field is 1, that is valid. If you remember, we designed the functions in a way so that the valid value returns a 1 and invalid values return a 0. So this condition will discard all the records with invalid join date. Let's execute it and take the count of records, 507. Now we also need to check something against the department name. We are not going to convert any values there. We are just going to check if there is a blank department name, which is also not acceptable because an employee without a department name cannot exist. So how we are going to do that? So I'm going to add the condition here using an AND operator, and the name is not null. Let's execute it and see if the number of records reduced from 507 to something else. Now 506 means one record was there with a blank department name, and we have discarded that also. And this way you can actually discard any records which you consider as not fixable. For example, let's see if there is a monthly salary which is blank, because an employee with a null salary or blank salary cannot exist. So let's add another condition here, and mcell is not null. Let's see the count, 505. So this way we can clean up as many records as possible or discard the ones that is not possible to be fixed before loading the data to the actual table. Now this is just a preview of the fixed data, and we need to add all the other remaining fields here because we are still missing the joining date and the birth date fields. So I'm going to make some modification so that the full data set with the clean data is displayed here. And in the second query, I am going to remove the original field which has the invalid data. So the first name I have removed. Similarly, the last name also I removed, and monthly salary. And then we will bring up all the other fields, that is the dname, join date, and birth date. Please note that before inserting to the actual table, we have to also maintain the sequence of the columns. Now let's execute it. And now we have only the clean data available with 505 records in the data set. And now we are ready to load this data to our actual table. If you remember, in the part 2 of this series, we created the actual table with the name, employee, salary data. So let's first see what is there in that particular table. Select star from EMP salary data Let's execute it. And it has all the records that we loaded after fixing the data issues using Python code. So what we are going to do, we are going to delete all these records which are already there, and we will reload it using our previous select statement, which has extracted all the records which were fixed using PL SQL. So to do that, we'll do delete from employee salary data, and all the 505 rows deleted. We have to commit this change to make it permanent. So click on this commit icon there with the green check mark. Now let's execute it again. It will return no records. Yes, it's blank now. Now we have to insert the records returned by the select query to this employee salary data table. And to do that, we'll use the command insert into employee salary data, and you can simply copy this select statement below. But while doing this, you have to make sure that the order of the columns or the fields are in the same in both the target table and the source select statement. And if we see that in the target table named employee salary data, we have employee ID, first name, last name, department, join date, monthly salary, and birth date is the order of the columns. And in the select statement, we see the employee ID is in the first position, which is correct. And in the second position, fname2 is there, which is also correct. The fname2 will be assigned to first name. And it doesn't matter what name is given or alias is given in the select statement for that particular field, because name is not going to be inserted, only the value will be inserted. And the value should match the target table's structure. So fname2 will be assigned to first name, lname2 will be assigned to last name, mcell2 it will be assigned to department, because this is the fourth column. So we have to put the department name in the fourth position. Then we see the join date is in the fifth position. So let's bring the ZD here. And then we see the monthly salary is in sixth position. So this line is correct. And then we'll remove the department name and join date from the bottom. And the seventh field is birth date. And we have BD here. Remove the comma. And now structurally both are the same. Now let's execute this. And we see 505 rows inserted. Let's commit the change to make it permanent. And now we are going to query the main table again. And there you go. We have all the transformed and cleaned up data loaded to the actual table. So we are ready to use this data for the data analysis. If you have watched the part 3 of this series, where we did our analysis using the dataset that we transformed and cleaned up using ETL process, then you don't have to watch the remaining part of this video, because data analysis phase will be the same, and it does not matter if you used ETL or ELT process to prepare the data for analysis. But if you have not watched the part 3, then please continue watching till the end of this video. Now let's understand what is data analysis or data analytics as a subject. Data analysis is a process of examining, cleaning, transforming, and interpreting data to extract useful insights, support decision making, and identify trends or patterns. It involves techniques such as statistical analysis, machine learning, and data visualization to help businesses and organizations make data-driven decisions. A data analytics project goes through a series of stages, and they are: first, defining the objective or the problem; second, identifying and collecting the data; third, transforming and cleaning the data; fourth, performing descriptive, diagnostic, predictive, and prescriptive data analysis; fifth, interpreting and visualizing the analyzed data. And along with these steps, to make and effective data analysis, you also have to take into consideration the facts that make most sense to the business and help them make decisions. These are called assumptions, and they need to be made in compliance with the business, organization, or industry standards. So we have briefly learned the theoretical aspect of data analytics. Now let's start with the practical activities, starting with defining the problem. So for this project, our objective or the problem is something like a medium-sized pharmaceutical company with little over 500 employees has been missing their yearly profit target for the last 3 years. They want to analyze the workforce structure and salary disbursement to see if they are overpaying in salary. And the assumptions for this project are: administrative departments like HR, legal, finance should not have employee count over 5% of the total workforce. Number of employees in quality assurance and research and development should be between 10 to 15% of the total workforce. Highly paid employee, that is HPE, limit should be 15 to 20% of the total workforce. Medium paid employee, that is MPE, limit should be 60 to 70% of the total workforce. Please note that this is a hypothetical scenario which is designed and created just for learning purpose. A beginner can understand the data analytics and the processes through this tutorial or the project. Now, as we have defined our problem, that is the first step of the project, and the second step of identifying and collecting the data, and the third step of transforming and cleaning the data. So next, we will start the step 4 of the data analysis phase of the project. Let's understand the analysis process through a diagram. So far, we have defined a problem, we have a data set, and we have a few assumptions. We will form a few questions which are relevant for the problem statement, and we will look for answers to those questions from the dataset. We have to form the questions in such a way so their answers lead us to a solution for the problem or help us find the root cause. Like, how much salary the company is paying in total, what is the department-wise salary disbursement, is any department overstaffed or understaffed, how much salary being paid to the HPEs or MPEs, what is the age group-wise distribution of the workforce, how many employees are retiring in the next 1, 2, or a couple of years, etc. Once we get the answers for our questions by querying the dataset, we have to compare the answer to the assumptions we made to see if they are violating or conforms to the assumptions. That will help us draw some facts or conclusions based on the answers. This process will be repeated until we get answers for all our questions and enough conclusions have been drawn. Then these conclusions will help us provide some recommendation as a solution to the problem. You can make as many questions you want, but the dataset should be able to answer that. It should be relevant to the problem statement, and the answer should help us narrow down to a solution. Now for a moment, just imagine how difficult it would have been to get answers for those kind of questions by simply looking into a raw dataset in a CSV format. But Microsoft Power BI will do this all for us in a very quick and easy way. Let's first start our Power BI application. So the application has started. Now press the blank report button to go to our main report or dashboard designing screen. And here, if you remember, the last time we created a data source connection using the system user, which we are not going to use anymore. So we have to first remove that connection settings so that it's not going to be used in our new project. To do that, first we will click on this transform data, this particular button here, then go to data source settings. And this is the existing connection settings that we used the last time. You can either delete it or you can modify the credentials there. Either way it will work. So I'm just going to modify the existing credentials in this connection settings. So to do that, click on the edit permission. Then press the edit button. And instead of system, this time we are going to use app_user, that is the name of the user, and the password appuser12345. Let's save it and press OK. And the close button. Now our data source settings have been changed. Now first of all, we are going to click on this get data button as we did the last time. Then select the more option, and then from the left hand side list we'll select database, and from the right hand side list we will select Oracle database. Click connect, and then again the same syntax that we used the last time. The server is localhost colon 1521 slash the service name, that is xepdb1. Then we are going to select the direct query option here and expand the advanced options, and in the SQL statement part we are going to specify our most basic SQL statement that we use to look at the data that we loaded, that is select star from EMP salary data. Let all these default options be selected and then press the OK button. And then you see a preview of the data which is loaded, and then we will simply press the load button here. And the data has been loaded behind the scene, and the query 1 connection has been successfully established. It will take a couple of seconds to give us the information about the data. For example, under the data ribbon we can see the query 1 is listed now. And now we are going to create our first visual on this canvas where we are going to design our analytical reports. So the first thing that we are going to do is to put a bar chart. There are a couple of different options you can see, like stacked bar chart, stacked column chart, clustered bar chart, etc. And out of these all, we are going to select this second one, that is the stacked column chart. Let's click it and it will automatically place that on the canvas. Then we are going to select the data to be displayed in this bar chart. So expand this query, and from there what we are going to display, the count of employees in each of the departments. Let's first try that. So what we are going to do, we are going to select the department field here first. So click on the checkbox, and then we'll select the employee ID field here. And if you see, not much meaningful data is there. So to make it more meaningful, what we are going to do, under these visualizations we have to make certain changes to this bar chart. So in the legend field we can see there's an employee ID mentioned, and what we want to do, instead of the legend we will just move it to our y-axis. So drag and drop the employee ID, and you see automatically it has changed to count of employee ID. So you see now we see a little more meaningful information here, and out of this we can see that the manufacturing and production department has the highest number of employees with an employee count of 101, and the second highest is the human resource with 53 employees, and the legal and compliance is also 53, like that. But every time you have to move the cursor over there to get the information. So instead of that, we want this to be displayed automatically. So when the visual is selected, we are going to click on the format your visual option, and there we will select the data levels which is currently off to on. And now we see that the employee count is also mentioned at the top of each of the graphs or the bars. So it is little more meaningful to us now. So this graph is more meaningful and convenient to see instead of looking at the raw data, where we can see which department has the highest number of employees and which is having the lowest number of employees and all those stuff. Now let's see this information in a different way. And this time, first click on a blank space there, and we will select the pie chart or a donut chart. So let's select the donut chart here. And this time what we are going to do, again we are going to select the department on the legend section, because you see the topmost field is legend and the value section is there. So when we select the department field here, automatically it will come to the legend field, and for the values we are going to select the employee ID. And we see the employee ID field is assigned to the details section of the pie chart or the donut chart. We don't want that, we want it to be in the values section. So we'll just drag and drop employee ID And you see immediately it has changed to a more meaningful picture here, where we can see the percentage-wise distribution of employees in each of the departments. This is also another meaningful way to see, and we see it's even giving us the percentage along with the actual count of employees. And it is giving us different colors for each of the departments so that we can distinguish them easily. Now let's change the width of this particular pie chart so that we can create some more room there. Let's drag the bar chart down. Now we can put some more visuals there in the form of some filters. Suppose we don't want to see all these departments together and we want to specifically focus on a particular department or a group of departments. Then what you can do, you can use this particular visual called slicer. So click on that and the slicer will be automatically put on the canvas. Let's put it at the top left corner because we don't need a lot of space for this. And when it is selected, we will simply click on the department field from the query. And you see it has automatically listed the departments there, and there are some checkbox. Now what you can do, if you want to select only a few departments, then you can select it from here. For example, if you want to see the customer support service, you click that and automatically the information displayed below in the bar chart and the pie chart will change to only the customer support and service department. If you want to select, say, couple of more departments, you can select those departments using control click. So press the control button and click on the other ones, and you can see, say, we have selected 4 departments, and you can see that only information related to those 4 departments are displayed below. So this is something which is very useful. Now when you do not select anything in this filter or the slicer, by default it is going to display all the departments. Now let's put one more visual there to get some more insight to the data in terms of the salary disbursement. So when none of these visuals are selected, then we are going to select one table. So a table is placed on the canvas, and what we are going to do, we are going to select the department here, and then we are going to select the monthly salary. Let's see what happens. And we see it is automatically summing up the salary against each of the departments. And this is very useful information. The total salary payment for the customer support and service department is 327, finance and accounting 398,000, etc. And the total amount of salary which is paid by the company for all the departments is little over 4.5 million. Now what we can conclude by looking at these all pictures and the information is something that we are going to put in a text box here. Let's increase the size to something like 16 and bold, and we'll simply put like facts. What we found here, number 1, total monthly salary is 4.5 million. Second, manufacturing and production has the highest number of employees as 101. Then the third conclusion is, by looking at the donut chart, we can see that the HR, legal and finance, these departments have over 10% of the total workforce of the employees. And how we can find that out? By looking at the different colors here, you can see which department has what percentage of employees. And for example, if you see the human resource is pictured with orange color, and we see there are 10.5% of the employees. If you want, you can even display this department name against each of the slices here. And to do that, select this and go to visualization properties, and then go to detail levels, and it is giving an option level contents, where it says the options we have like category, data values, percentage of total, category data value, category percent of total, data value percent of total, and all detail level. If you select all detail level, it will give all the information there, but it will make a little messy in this small space. But so if you want, you can keep it or remove it. It's up to you. It is also easier to see which color is which department here. And instead, and if you like this particular option, then you can actually remove the legend part. So you go to this legend option and switch it off. So the legend is gone, and instead we are able to see the slices with the percentage of employees and the number of employees also, along with the department name. So HR has 10.5%, legal and compliance has 10.5%, and finance and accounting has 10.1%. So we can conclude that HR, legal, and finance has over 10% of the workforce. If you remember, we had an assumption like the administrative departments like HR, legal, finance, etc. should not have more than 5% of the total employees. So that's the reason this is an important fact, that these departments are over-allocated with employees. And next, we are going to add a new page to our report. To do that, click on this plus button here to add a new page. And this time, we are going to analyze a few more different data, like what is the amount of salary paid against each of the department and their percentages. So this time, we are going to add a pie chart. Let's bring it to the middle, increase the size, and then we are going to select the department field first, and then monthly salary. And you see the values are added by summing them up against each of the departments, and it is automatically giving us how much salary is paid and what percentage of the salary is paid for that particular department. Now, if you are interested to see only a few selected departments, then again we can do the same thing by adding a slicer here to filter out the unwanted departments. So I added a slicer, and there I am going to select the department field. And if I select, say, only the customer support service, and then control click, say, information technology, and third, say, quality assurance and control, we see only the information relevant to these three departments. Let's unselect them. And now what we can conclude from this particular slide or the report, we are just going to put it below in the text box. Let's reduce the height and increase the width, and we will change the size to 16 and bold. What is the significant conclusion we can draw from this particular picture is we see a bigger slice here that belongs to this purple department, that is manufacturing and production. So we'll put here manufacturing and production department has the maximum salary payout of 822K. Number 2, let's see which is the second highest salary paying department, and in this picture we can see that it is the pink color department, that is legal and compliance, which is paying 570K. So the second conclusion is legal and compliance department is the second highest salary paying department. And the third conclusion that we can put here is who is paying the lowest salary. And here we can see the smallest slice here is the blue one, that is customer support and service. So customer support and service is the lowest in paying salary. And one vital piece of visual is missing here, which will make it little more informative. That is, we also added that in the previous page. We can in fact bring it to here. That is this particular one, which is listing us the salary payout against each of the departments and the total salary payout. So what we can do, we can simply copy it and go to the second page and paste it. Adjust the size a little. And this has completed the second page. Now let's add the third page to our report. And in this page, we are going to analyze what is the amount of salary paid against each of the salary groups. Basically, there are three different salary groups. The first one, highly paid employee group. Second one, medium paid employee group. And the third one, low paid employee group. So how we are going to analyze that? So we have to construct a SQL query first, which we are going to add to our report. And to do that, first we will go back to our SQL developer window to write the query. And I am using SQL query here because it is easier to write and the code is reusable. Structured query language or SQL is a easy to learn yet powerful language, and it makes your life a lot easier when working with Oracle database or even other databases. So this is going to be a simple query. So how we are going to identify which particular employee is from which group? Using this select query, select employee ID, comma, we have to start a case structure in SQL, that is case when monthly underscore salary is greater than or equals to $10,000, then it will be categorized as, say, HPE, that is highly paid employee. Let's copy this line. And when the monthly salary is greater than equal to 7,000, then it is considered as a medium paid employee. So MPE, and else part will determine that the employee is actually an LPE. So if it is not falling under any of the first two lines or the groups, then the employee will be from low paid employee group. And then we will have to end this case structure. And we will give an alias or name to this particular field, which is created here for the pay group as pay underscore group. And then from the table name, EMP salary data. Now first let's execute it and see what it returns. It is listing all the employee IDs, and against the employee ID, it is also listing whether it's an LPE, MPE, or HPE. So we'll use this query and we'll take it to our Power BI application. Please note that the salary groups I am mentioning here are just for demonstration purpose, and they are customizable based on different organization policies, salary structures, countries, etc. Also, instead of creating a separate SQL statement to extract this information, you can use Power BI features like adding a measure, columns, formulas, etc. But I find it easier using a SQL statement, and also it is reusable. We are going to create a copy of this first query and we'll just modify the contents. To do that, select on these three dots to the right of the query and then select the edit query option, and this will open the Power Query editor. And here we see the first query is listed there. We are simply going to create a duplicate of this query. We'll rename it as, say, query 2. And then when the query 2 is selected, we'll click on this Advanced Editor button. And in this editor, we are going to simply replace this query with the one that we just tested for the pay group. And then click on the Done button. And it is going to execute the query. It will ask for the permissions. Just click on this Edit Permission. And then click on the Run button. and it has listed all the employee and their pay group. Now close the Power Query editor and it will ask for applying the changes. We'll just click on the yes button and then it will apply the changes to the main editor where it is loading both the queries now, query 1 and query 2. And now we can see there are two queries listed under the data ribbon, query 1 and query 2. And query 2 has just two fields there, employee ID and pay group. And in this third page, first we are going to add a pie chart. Let's increase the size, and then when the visual is selected, from the second query we are going to select pay group and then employee ID. And again we have to drag this employee ID to the values field, and now we can see relevant information there. The orange colored slice, that is the medium paid employee, is 299, which is the 59% of the total workforce. The highly paid employee, that is with the blue color, with 156 employee and with 30% of the workforce. And the low paid employee is 50 in number and 9.9% of the total workforce. And also we are going to create another pie chart or a donut for the total amount of salary paid against each of the salary groups. So to do that, we add the donut chart. Now this is going to be a little tricky. I'll show you in a moment. Let's expand it. And we see that the query 2 has only two fields there, employee ID and pay group. There is no salary field. It only belongs to the first query. In that case, actually we can join them together. And to join them, we need a common field between them. And we see that query 1 has employee ID and query 2 also has employee ID. So we'll be able to use that. But to establish a join between these two queries, we have to go to the model view in the left sidebar. So click on that. It will list out both the queries. And from here, we will drag the employee ID field from the query 1 to the employee ID field of query 2. And this is called a relationship between the query 1 and the query 2. In fact, they are representing two data sets. Now, below we can see the cardinality is 1 to 1, which is because in both these queries or the data sets, the employee ID is unique. And make this relationship active, we need to check this box and the cross filter direction, both, that is okay. And then we'll save this relation. There will be a connection between these two data sets. Now we'll go back to the report view by clicking on this topmost icon in the left sidebar. And then in the donut chart, we'll be able to reference fields from both these queries because they have a relationship now. So what we are going to do here, first we will add the pay group and then we will add the monthly salary. Let's see what it gives us. And here now we can see the medium paid employee group is getting a total salary of $2.53 million and the highly paid employee group is getting a total salary of $1.67 million and the low paid employees are getting $0.33 million and also their percentages. Now what we can conclude from these two graphs or the charts, we'll put it in a text box there. Then click on the text box and the first total monthly salary for HPEs is at $1.6 million. Number 2, total monthly salary for MPEs is at $2.5 million. And the third conclusion is percentage of HPE to the total workforce is 30%. As we can see here, total number of HPEs are 156, which is the 30% of the total workforce. So it is a violation of one of the assumptions that we made, which says HPE limit should be 15 to 20% of the total workforce. Now let's add another page to do some more analysis. It is going to be a predictive analysis considering 67.5 as the official retirement age for the employees. This time we are going to analyze the employees by their pay groups and their age groups. To do this kind of analysis, again we need a different query, and we are going to construct that query using our SQL developer application. So let's bring it up. So we'll use the previous query that we used to identify the pay group of the employees, and we'll just modify it. So what we are going to do, so we are going to use the first case structure that we created to find out the pay group. We'll just keep it as it is and add another case structure for the age group. And we are going to modify the second case structure to give us the employees age group. And the logic we are going to use is to find out the number of years between the current date and the employee's birth date. And if the number of years is 65 or more, then that employee is considered as a retiring employee, because in the next 2 or 2.5 years, he will reach the retirement age and he must be retired. And if the number of years between the birth date and the current date is greater than 60, then that employee is going to be considered as senior employee, and which is going to return within the next 5 or 7 years. And if the number of years between the birth date and the current date is 50, that is the employee is 50 years or more in age, then he is considered as a young employee who is still having more than 10 years to retire. And with this logic, we are going to determine the number of years between the two given dates using the months between function in Oracle. So how we are going to do that? First, we will remove the existing condition and we'll use the months between function. It's an inbuilt function in Oracle, and we are going to pass two dates here. First one is the sys date, which represents the current date when you are running this SQL query. And the second date is the birth date of the employee. And as it is going to give us the months, so what we want to do, we can do a comparison as greater than 65 multiplied by 12. And then the group will be retirement is greater than 65. Then for the second part, and next we are going to put the second condition for the senior employees, like months between sys date and birth date greater than, and instead of 65 we are going to put 60 here multiplied by 12. Then we will be considering that employee as a senior employee and greater than 60. And the third condition that will determine the mid-aged employees, and here we'll simply change the 60 to 50, and the group it will return is mid-age and greater than 50. And the last condition, that is if the employee's age is not falling in any of the top 3 groups, then by default it is going to be a young employee. So we are going to put as young, and then end the case structure, and we are going to name this field as, say, age group. Let's remove this space and then let's run it to see what it returns. And now we can see that employee ID, pay group and age group, all these things are listed there. And we are going to use this query for our 4th page in the report. Let's go back to our Power BI window. We have not saved the report yet, so let's save it also. We can name, say, employee salary analysis. And first we are going to add the third query here, and to do that, again, as we did in the last time, click on the three dots against any of the queries listed and go to Edit Query, and the Power Query Editor will appear, where we are going to create a duplicate copy of an existing SQL query, and we'll rename it as, say, query 3, and then click on the Advanced Editor, and we will replace the existing query with the one that we just created and copy it from our SQL Developer application. Click on the Done button, click on the Edit Permission, click on Run button, and it has displayed the output. Now we're going to close this window, apply the changes yes. It will take a few seconds to load the third query, and all the three queries are loaded, and we can see in the right hand side under the data pane the query 3 is listed there. And here also the same way, we have to establish a relationship between the query 3 and query 1 so that the fields which are not listed in query 3 can be taken from the query 1. To do that, again we'll go to the model view, and we will drag the employee ID field to the employee ID field of query 3, and it is going to be the same as the previous one-to-one relation. Make this relationship active and click on the Save button. Then go back to the report view, and here we are going to add one bar chart or the column chart again. This second one, that is stacked column chart, click on that, and that will place it on the canvas. It's increase the size of the chart, and then we are going to select the age group from the query 3, then employee ID, and then pay group. And we have to make some changes here because it's the default view. So what we are going to do, the age group will be in x-axis, then count of employee, that is going to be in y-axis. It will automatically take the count of the employee ID because we are summarizing it in y-axis, and the pay group will be in the legends field. And now it is giving us a more meaningful information. To understand this chart, first we have to see the pay group legend. So the blue color is the HPE, the dark blue is LPE, and the orange color is MPE. Now we can see that most of the MPEs or medium paid employees are in the young group, and only a few number of LPEs are in the young group. In the second bar, we can see the highly paid employees are mostly in the retirement age of 65, and only a few of the employees that are from the LPE belongs to the retirement age, and there is a very little number of MPEs that belong to the retirement age. And in the third bar, we can see mid-age employees, that is the employees with age greater than 50, they belong to MPE. And the senior employees with the age over 60, mostly they are HPE, and second they are MPE, and a very little as LPE. So we can conclude from this particular chart that mostly high paid employees are in the retirement age group or in the senior age group, which are going to be retired in the next couple of years, which will bring down the highly paid employee number in the organization, and thereby also reducing the salary disbursement because they are highly paid employees. Now let's another pie chart here to get some more meaningful information. So click on the pie chart. Let's put it at the top, increase the size, and then here we are going to put the age group first, and then monthly salary, and this will give us actually the monthly salary by age group, where we can see that the employees in the retirement age group, that is over 65 years of age, are getting 1.49 million, which is roughly 32% of the total salary disbursement. And the second one is the young age, who is getting 1.3 million, which is 29% roughly. And the third one is the mid age, which is getting roughly 1 million in salary and 22% of the total salary. And the senior age employees are getting 0.69 million, which is roughly 15% of the total salary disbursement. Now we want to put some more information in this bar chart so they become more informative. So select it and go to the format visualization options, and under that we will select the data labels and total labels, which will give us the count in the bar chart itself. For example, you see now the MP count is 161 and the total count in the young group is 174, etc. Now it will be easier for us to make the conclusions by looking at the numbers. So let's select a text box, adjust the size, it will be bold and 16. And the first conclusion that we are going to make is 120 HPEs will retire in the next 1 to 2 years, which we can see in this second bar chart. The second conclusion is 36 HPEs will retire in the next 5 to 7 years, which you can see in the fourth graph. Because considering 67.5 as an official retirement age for the employees, this is the age group for senior employees. Then the third conclusion we can make here is the retiring HPEs will result in a salary reduction of 1.5 million approximately. Where you can see that in this second pie chart, we see that the slice that represents the retirement age group is getting a salary of 1.49 million, which is roughly 1.5 million. So this is the third conclusion. Now let's add another page to the report as page 5, and this will have nothing but our recommendation, because we have already made a couple of conclusions in the first page. If you see, we have made some conclusions here, then in the second and the third page and the fourth page. Now we are going to summarize all of them to put some recommendation for the company. So what will be our recommendation? It will be based on what we have concluded in each of the analytical report pages and what we have assumed. If you remember, our problem statement was to see if the company is paying a lot of money as salary disbursement and they are not meeting their profit target because their salary disbursement is more. So in this case, what we have to do, because we have seen a lot of issues which are actually violating the assumptions that we made. Some of the departments are overstaffed, number of highly paid employees are more than the recommended limit, etc. So we are going to put some recommendations which will mitigate those issues. The first one, offer early retirement with benefits that will reduce the number of employees and the salary disbursement on some of the departments. Of course, you are going to offer this to the employees in the overstaffed departments. 2, lower yearly hike in salary for HPEs and MPEs. It's important because HPEs and MPEs are already getting a huge amount in salary, and in that case a small percentage value will also result in a large amount in total, and by lowering the yearly hike, the total expenditure in the salary disbursement can be reduced. The third one, stop recruiting in the overstaffed departments, because we have seen that some of the departments like HR, legal, etc. are having more than the recommended number of employees for which we made an assumption before. Then the fourth recruitment preference will be for MPEs or LPE to HPE. It means that instead of recruiting the highly paid employees, the company should focus more on recruiting medium paid or low paid employees. Then the fifth one, encourage internal department transfers than new recruitment. For example, we have seen that some of the departments are already overstaffed. So the company can move some of the employees from the overstaffed departments to the other departments which are understaffed or going to recruit new people. And with these recommendations, you can conclude your data analysis. Now we have seen the power of Power BI, how it has simplified the analysis process with a lot of insights and helped us draw conclusions from a raw dataset. A skilled analyst can do even more analysis and draw conclusions to provide more appropriate solutions to the problem. And with this, I am concluding this series about a simple project on data analysis. So viewers, please provide your feedback in the comment section of the video and hit the like button if you found it useful. That will mean a lot to me and help grow this channel.